In this video, we will solve the questions asked in UGC Net Economics paper of June 2024. This is the second part of this series. You can check out the first part also on this channel. The question is, suppose the initial equilibrium level of GDP is $1,000 billion. If marginal propensity to consume is equal to 0.75 and government spending increases by $100 billion, then expenditure multiplier and new level of GDP respectively will be. Options are being given. We need to find out the correct option. Okay, so what we are being given? We are being given the initial equilibrium level of GDP. Let's denote it by Y star. That is the initial equilibrium level of GDP, which is equal to $1,000 billion. Okay, also we are being told that marginal propensity to consume is equal to 0.75 and government spending increases by 100 billion. That is also being given as, that is the change in the government spending is equal to 100 billion. We need to find out the expenditure multiplier and new level of GDP. Now what is the formula for expenditure multiplier? Let's denote it by K. So expenditure multiplier is simply equal to the change in the GDP due to the change in the government spending. Okay, and which is equal to 1 upon 1 minus the marginal propensity to consume. Okay, so which will be equal to 1 divided by 1 minus, what is MPC? That is 0.75, 0.75, which comes out to be 1 upon 0.25, and it can be written as 1 upon 25 upon 100, and which is equal to 100 upon 25 reciprocating. So we get 25 ones are 25 fours are. That means the expenditure multiplier is equal to 4. What does it tell us? It simply tells us how does the GDP change, or how much will the GDP increase if there is increase in the government spending. That means if government spending increases by 1%, okay, or increases by $1, so income change in the GDP will be increased by 1 into 4. 4 is a multiplier, so change in the equilibrium level of income will increase by $4. Okay, now we need to calculate the change in the GDP due to the change in the government spending. Okay, that is the change in the income due to the change in the government spending, which is equal to this 1 upon 1 minus MPC, which we calculated as 4. Okay, change in the income we are supposed to find. Change in the government spending, that is being given us as 100, should be equal to 4. Cross multiplying, so we get the change in the level of GDP will be equal to 100 into 4, which is equal to 400. Okay, now what will be the new level of GDP? So new level of GDP will be equal to, let us denote it by Y superscript n. It will be equal to the initial equilibrium level of GDP, that is Y star, plus the change in the GDP due to the change in the government spending, which is del G. So that will be equal to, so new level of GDP will be, initial GDP is equal to 1,000 plus the change in government spending is 400, which comes out to be $1,400 billion. Okay, so the correct option should be equal to, so multiplier is 4 and new level of what we call the GDP will be equal to 1,400. So 4 and 14, so that is the fourth option will be the correct one. Is a monopolist produces two goods X and Y. The demand function for each good is given as, that is the inverse demand function for good X is being given as, that is P subscript X, that is price of X, which is equal to 36 minus 3X, and price of Y is equal to 56 minus 4Y. These are the two inverse demand functions for the two goods. We have to find out the maximum revenue here. Okay, so what will we do? we need to find out the total revenue function first. So let us write what will be the total revenue for the monopolist. It will be equal to price of good X times units of good X produced, plus for the second good, that will be the price of good Y times units of good Y produced. Okay, this will give us the total revenue first. That implies total revenue will be equal to, so Px is this function 36 minus 3x, to this we multiply by x, plus Py is this very function 56 minus 4y, to this we multiply by y. So what will be the total revenue? Total revenue will be equal to, multiplying this x to each of these terms, it becomes 36x minus 3x square. Similarly, we have 56 times y, 56 times y minus 4y square. This is our total revenue function, and we are supposed to find out the maximum revenue. So how do we calculate the maximum total revenue, since we have the two variables here? Okay, so let me write in place of total revenue is a function of two goods, and let me write it like this. So let's write total revenue is a function of two goods, that is f of xy, which is equal to 36x minus 3x square plus 56y minus 4y square. Okay, now to find out the maximum revenue, we need to find out actually the relative maxima. Okay, so this question is actually related to maxima and minima. How do we find out the relative maxima or minima? First thing is, we take the first derivative of this function partially with respect to x and y. Okay, that is the f subscript x means the partial derivative of this function with respect to x. That means, and we set it equal to 0 to find out the critical points. I will explain it. So we take f subscript x, that is the partial derivative of this function with respect to x. The derivative of x in the first term is 1, so we are left with 36, minus derivative of x square in the second term is 2x, so 2 3s are 6x. We set it equal to 0. We are taking partials with respect to x, so the derivative of the second last two terms will be equal to 0 because we are taking partials with respect to x. Okay, now let us solve this. It implies 6x is equal to 36. Dividing both sides by x, we will get, dividing both sides by 6, we will get x will be equal to 6. This is our one critical point. So first thing is, we need to find out the critical points. Similarly, we take the second partial, that is f subscript y, that is the partial derivative of this derivative total revenue function with respect to y. So derivative of y in the third term is 1, we are left with 56 minus derivative of y square is 2y, so 2 4s are 8y, and we set it equal to 0, implies 8y is equal to 56, implies dividing both sides by 8, so y will be equal to 7 or 7. So we got the two critical points. Second is, we need to check for the relative maxima. So we are also we need to calculate the second partial, that is second direct partial, second order direct partial, that is f xx, that is the second derivative of this function with respect to x. F subscript xx means the second partial derivative with respect to x. So the derivative of a constant is 0, derivative of x is 1, so we are left with minus 6. Similarly, we find the second direct order direct partials with respect to y, f y, that is the derivative of this function with respect to y. So derivative of a constant is 0, derivative of y is 1, so we are left with minus 8. Okay, we also need to find out the second order cross partials, that is f of xy. That means the derivative of this function with respect to y. Since we have no y in this, the derivative of 36 is 1, derivative of 6x will be also equal to 0. The derivative of 36 is 0, derivative of this term is also equal to 0 because we are taking the partials, second partial with respect to y. So it will be equal to 0. Okay, and similarly we need to find out f of yx. So the derivative of this function again with respect to x, so since no x is involved, its derivative is 0. Now what are the conditions for maxima? So conditions for relative maximum, we need to find out whether these conditions are satisfied or not. Okay, so we find out the critical points, we need to check whether they are actually at the relative maximum. So first condition is that, and let me be specific here, for relative maxima, so first derivative should be equal to 0, f subscript x, we set it equal to 0, f subscript y, we set it equal to 0. I am explaining. Now second partial is, that is f x, for relative maxima it should be less than 0, that is f y, it also should be less than 0. And third condition is the product of second order direct partials, that is f x times f y, it should be greater than f of xy times f of y x. Okay, here we can see second partial both are less than 0. Okay, these are negative. This condition is fulfilled. This we calculated, the critical point is 6 and 7, and this condition is also fulfilled, that is fxx, that came out to be minus 6, times fyy, it came out to be minus 8, and fxy and fyx, it is 0 into 0. Here you can see 8 6 are 48. I guess it is 48, and here it is greater than 0, so all the conditions are fulfilled here. Actually we didn't need to go further here, so I was just trying to explain how do we calculate the maximum here. So for maximum, we set the first derivative is equal to 0, find out the second order direct partials if they are less than 0, and this condition, then we say the given critical points are actually the points of relative maximum. Okay, so here all the conditions are fulfilled, that means these are the our critical points which satisfy the relative maximum principle here. Now to find out the total revenue, now you can simply plug the value of x is equal to 6 and y is equal to 7 into the total revenue function in this equation. Okay, so let us do that very thing if I have the space left. So in this equation we plug, so total revenue will be equal to, we have 36 into the value of x, we got 6, then we have minus 3 x square minus 6 square, which is 36, then we have plus 56, the value of y is 7, plus then we have minus 4 y square minus 7 square, which is 49. We need to solve this again. So total revenue will be equal to 6 6 are 36, 6 3 are 18 arda kunu ako. So this is 216 minus 3 6 are 18, 3 3 are 9 tageda, plus we have 7 6 are 42, 7 5 are 35, 36 37 38 39. So we get 392 minus here 4 9s are 36, 4 4 are 16, 17 18 19, so 196. Let us find out the total revenue now. Total revenue will be equal, so this is the positive term, this is the positive term, let's add them. Shat is 8 now tage the that is 5 tage, so 6 or 8 minus, these are the negative terms, we can add them up. So 8 plus 6 is 8 so the 9 now tage the, then we have 1 plus 1 plus 1, which is 2. So total revenue will be equal to 8 minus 4 is 4, 0 go 0, shan is it. Let me see if I have done it correctly or not. 6 minus, so we have 196, so it is here 304. Okay, so because 8 8 plus 6 is 14, then we have 9 plus 0 is 0, then we have 1 of the carry, so it becomes 10, 1 is carried, so we have 1 plus 1 which is 2, and the carry 1, that is 3, so it is equal to 6 minus 3, which is equal to 3. So the total revenue will be equal to, maximum total revenue will be equal to 304. So the correct option should be this option. The question is, a firm's production function is being given as says that Q is equal to 12 minus 1 upon L into K times L plus K. L and K denotes the units of labor and capital employed. Q is the total output. The prices of labor, capital and output are being given as says $1, $4 and $9 respectively. We have to find out the maximum profit. Okay, so let's write the given production function, that is Q. Q is equal to 1 upon LK times L plus K. Okay, this is the production function. Also we are being told that the price of labor, let's denote it by P subscript L, it is being given as $1. Price of capital, let's denote it by P subscript K, it is being given as $4. And price of output, let's denote it by only P, that is P is the price of the output, that is the price of Q, which is being given as $9. We are supposed to find out the maximum profit. Okay, so first thing will be, we will form the profit equation. What is the profit function of a firm? So we know profit for the firm will be equal to the total revenue minus the total cost. Okay, now let us see what is the total cost. So what will be the total cost for this firm? Total cost will be equal to the price of labor times units of labor employed plus price of capital times units of capital employed. This will be the total cost for the firm. What about total revenue? Total revenue will be equal to price into output. So can I write profit will be equal to total revenue is P into Q minus total cost is this function, that is price of labor times units of labor employed minus, so here we have minus, it will become minus, then we have minus price of capital times units of capital employed. Okay, so let me rub this out here. Now we are being told that price of labor is 1, price of capital is 4 and price of output is 9. So can I write profit will be equal to, so in place of P I write 9, that is the price of output, so 9 9 into Q minus price of labor is 1, so we write only L, minus price of capital is 4, so I write PK is 4 times K. This is the profit function. Let us further expand this. Now we know Q is this very term. Okay, if I write Q is equal to, can I write it like this, L plus K divided by LK, and it will be equal to L upon LK plus K upon LK. Okay, so I am just expanding this basic rules of addition when we have the numbers in fractional forms or the variables in fractional forms. So here L and L gets cancelled, K and K gets cancelled, we get 1 upon K plus 1 upon L. Okay, so we have profit will be equal to, so we have 9 in place of Q, sorry, we have also 12 here, sorry for this mistake, so I have 12 minus this stuff, so we have 9 times 12 minus, okay, then we have, so this stuff I solved it like this, it became 1 upon K. So since we have minus here, so it will also become minus into pluses, minus 1 upon L. Then we have minus L, this minus L, then minus 4K. Okay, I hope I am making myself clear here. What I have done here, I will simply expanded this in this form. So actually we were having 12 minus this setup. Okay, so this minus is to each of this terms, so it becomes here 12 minus this stuff, so it will become 12 minus 1 upon k minus 1 upon L. I forgot to mention the 12 in the production function. So this is our 12 minus 1 upon k minus 1 upon L, and we multiply it by the price of output, that is 9. This is our profit function. Okay, now what is the first condition for profit maximization? Since we have two variables here, I will write a first order condition for profit maximization. Profit maximization requires that the marginal profit with respect to k and L should be equal to 0. That is, the derivative of profit function, or let me write it here, I have the space, the derivative of profit function with respect to, so I don't have the space here, the derivative of profit function with respect to L, it should be equal to 0, and the derivative of profit function with respect to k, it should also be equal to 0. So we need to find out these two derivatives. These are the partial derivatives here, obviously. So can I rewrite it like this? So let me rewrite the profit function to expand it. So profit is equal to, profit is equal to, so multiply this 12, so 9 2s are 18, 9 1s are 9, target 10, we have 108 minus 9. I am multiplying this 9 to each of these terms, then we have minus 9 upon L, then we have minus L minus 4k. This is our profit function. Okay, now we need to take the derivative with respect to labor first, that is the derivative of profit function with respect to labor, it should be equal to 0. Let's take the derivative. Derivative of a constant is 0, derivative of k, derivative of the second term will be also equal to 0 because we are taking the partial with respect to L. Derivative of 9 upon L, it will be equal to, so the derivative of 1 upon L is equal to, so we can write it like this, L raised power minus 1. If I transpose denominator to numerator, exponent sign changes. Now the derivative of L raised power minus 1 is equal to, exponent becomes coefficient by power function rule, we have minus 1, L raised power, and exponent is subtracted by 1. So we get minus 1 into L raised power minus 2. Can we write it like this? Minus 1 upon L square. If I transpose this back to the denominator, exponent sign will change. Okay, since we have this minus also here, so we will get it will, so the derivative of 1 upon L is minus 1 upon L square. Since we have minus also here, so minus into minus will become plus, so we will get 9 upon L square. Similarly, the derivative of L in this third term or fourth term is 1, and we set it equal to 0, solving, so we will get 9 upon L square is equal to 1, which implies L square is equal to 9, or L will be equal to under root 9. If I transpose this square, it will become under root, so L will be equal to 3. So units of labor employed will be equal to 3 for profit maximization. Similarly, we need to find out the derivative of the profit function with respect to k. Okay, this time we take the partials with respect to k. Now derivative of a constant is 0, derivative of 9 upon k will be equal to, so we have minus also here, so minus into minus will become plus, as I have explained it here. So it becomes 9 upon k square. Derivative of k in the last term is 4, so we are left with, derivative of k is 1, so we are left with minus 4, and we set it equal to 0. That means the partial derivative with respect to capital. Okay, solving it, so we have 9, or let us write it with another color to highlight this. So we have 9 upon k square is equal to 4, or we will get cross multiplying, we get 4 times k square is equal to 9, or k square is equal to 9 upon 4, or k will be equal to, it will become under root of 9 upon 4, so k will be equal to 3 square upon 2 square, so k will be equal to under root of 3 upon 2 whole square. Square root gets cancelled, so k will be equal to 3 upon 2. That means the number of capital units employed will be equal to 3 upon 2. So we got L is equal to 3, K is equal to 3 upon 2. Then what will be the maximum profit? So simply plug the value of L and K. We need to plug the L and K into the profit function. So this is our profit function, or let's put it in this equation. So our maximum profit will be equal to, so profit will be equal to, so we have 108 minus 9 upon K. K is 3 upon 2. Okay, so 9 upon 3 upon 2. Then we have minus 9 upon L is 3 minus, then we have L again 3 minus 4, the value of K is 3 upon 2, 3 upon 2. Let us solve this. So we have 108 minus, so we have 9 upon 9 upon 3 upon 2, so it will become 9 into 1 into transposing, it will get reciprocated and multiplied. 3 ones are 3 twos are, so sorry, 3 ones are 3 threes are 9, so we get 3 twos are 6, so this becomes 6. So we have 6 minus, so 9 upon 3 is 3, then we have minus 3, so 2 ones are 2, twos are 4, so it also becomes 6 here. So maximum profit will be equal to, so Kshetra now the other, we get 108 minus 18, which comes out to be 0, so now, so the maximum profit will be equal to 90. Okay, so the correct option should be this option. Next question is, the rule of thumb to express price directly as a markup our marginal cost is. Options are being given, we need to find out the correct option. Okay, so what is meant by the markup pricing? So the markup pricing is the price that a monopolist is able to set above the marginal cost. Okay, that's called the markup pricing. Now we use the learner's index of degree of monopoly formula to find out the correct option. In this case, that is the price directly as the markup our marginal cost. So from the learner's index we know that at equilibrium, price minus marginal cost upon price is actually equal to minus 1 upon elasticity of demand. The relationship between price, marginal cost and elasticity of demand is shown by this very relationship. Okay, you know it from the learner's index. So let us solve it further. So expanding this, so we have P upon P minus MC upon P is equal to minus 1 upon E. So P upon P is 1 minus, we get MC, that is marginal cost upon price, is equal to minus 1 upon E. Transposing this term here and this term there, so the signs will change. So it becomes 1 plus 1 upon E, okay, will be equal to MC upon P. Okay, let's do the cross multiplication here. So we will get P times 1 plus 1 upon E is equal to MC, which implies P will be equal to, so if I transpose this term to RHS, it will get divided, so we will get MC upon 1 plus 1 upon E. Okay, so the correct option should be the first one. Okay, this is from the learner's index. How do we calculate or how do we express price directly as a markup over the marginal cost? So this is the relationship. Next question is, In an economy, if marginal propensity to save is 12%, productivity of capital is 25%, and GDP is equal to 150 billion a year, then based on Harrod model, to maintain full employment, at what rate income must grow? Options are being given. We need to find out the correct option. Okay, so what we are being given? We are being told that marginal propensity to save, which is equal to what we call, which is here 12%. So this is our what we call the saving ratio, also saving income ratio, which is equal to 12%. Productivity of capital, what we also call the marginal productivity of capital, it is being given as 25%, and income is being given as 150 billion. We need to find out, to maintain full employment, we need to find the rate at which income must grow. So the basic Harrod equation is that growth of income, that is denoted by G subscript Y, should be equal to savings income ratio, that is S upon the incremental capital output ratio. Okay, so savings S upon ICOR, this is the equation for growth rate of income to maintain in case of Harrod model. Now marginal propensity to save is 12%, that means this is our S. Now what is incremental capital output ratio? Incremental capital output ratio is the ratio of investment to growth, which is equal to the reciprocal of the marginal product of capital. Okay, so our ICOR is actually the reciprocal of the marginal product of capital. What does it tell us? It simply tells us higher the ICOR, or higher the incremental capital output ratio, lower the productivity of capital will be, or the marginal efficiency of capital. Okay, so what will be ICOR? That is 1 upon marginal product of capital is 25%, so it is equal to 1 upon 0.25, which is equal to 1 divided by 25 upon 100, which comes out to be 100 upon 25, which is equal to 4. So our incremental capital output ratio is 4. So our growth rate of income should be equal to, so we have 12% as marginal propensity to save, which is 12% upon the incremental capital output ratio, which we calculated today is 4, so which will become 3%. Okay, next question is, if the income elasticity of demand for money is low, then options are steeper will be LM curve, flatter will be LM curve, steeper will be IS curve, and flatter will be IS curve. Okay, so we are being told that the income elasticity of demand for money, okay, when we have the demand for money in this case, so this is not related to the IS curve, so these two options should be incorrect. Okay, so what does LM curve tell us? LM curve shows us, if I draw it here, it shows us, let us say this is our LM curve. We have the GDP on the horizontal axis and rate of interest on the vertical axis. LM curve shows us different combinations of income and rate of interest, where what we call the demand for money is equal to supply for money. Okay, so what is the formula for demand for money? First we need to find out that very step, then we can explain this income elasticity of demand for money. Now at equilibrium, what happens? This shows the money market equilibrium. Obviously I will not go into that detail. So at equilibrium, money demand for money should be equal to the supply of money. Money demand has two components here. Okay, that is, money is demanded for transactionary purposes, and money is also being demanded for speculative purposes. That's denoted by M subscript Z, and we assume that the money supply is fixed by the central authority. It is an exogenous variable. So transactionary demand for money is the positive, that is demand for money, if I write it like this to make sense. So demand for money is a positive function of income and negative function of, let's denote H subscript, sorry, HI. That shows us that the demand for money is the positive function of income and negative function of rate of interest. It says if income increases, demand for money will increase, and if interest rate increases, demand for money will decrease. Okay. Now to find out the LM equation, we equate demand for money with supply for money. That means KY minus HI should be equal to money supply, which is fixed. Solve for Y. So we have K times Y is equal to MS. Transposing it becomes HI. Now this K denotes, here this K denotes the income elasticity for demand for money, and this H shows us the interest elasticity for demand for money, or income sensitiveness for demand for money, and this shows the interest sensitiveness for demand for money. Okay, so let us solve for Y. So Y will be equal to 1 upon K MS, okay, times MS plus H upon K times I. This is our LM equation. Now this, the first part shows us the intercept of the LM equation, okay, because money supply is exogenously fixed, K is also, you know, a constant number, so this gives us the intercept. Let us say this is the this term shows the intercept. And what is the slope of this LM function? Slope of the function denotes upon, sorry, depends upon H upon K ratio, and we know that H is the interest sensitiveness for demand for money, and this K denotes the income sensitiveness or income elasticity for demand for money. Now here you can see, if this K, the question tells us if income elasticity for demand for money is low. That means if the value of K is low, okay, compared to H, what will happen? This whole term, sorry, this H upon K will increase. Obviously, if the denominator is smaller compared to numerator, so this whole term will increase. That means the slope will increase. That means it will become steeper. The thing is, let us say we have H upon 4. It changes to, let us say in place of H we have 10. Initially we have 10 upon 5, which is 2, and if it becomes low, that is from 5 to, let us say 2, so it becomes 4. Obviously, when this K decreases, this slope becomes steeper here. Okay, that means the correct option should be that when the income elasticity of demand for money is low, then the LM curve will be steeper. The correct option should be first option. Next question is, find the general and particular solutions for the differential equation dy upon dx minus 6x plus 2 is equal to 0. Okay, I have not written the options here because those would have taken the much space here. Okay, so how do we solve this? So first we apply here what we call the separation of variable method. That is, can I write it like this? Dy upon dx is equal to, transposing these terms here, 6x plus 2. Okay, then transposing this dx here, so we will get dy is equal to 6x plus 2 times dx. Okay, so first we separate the variables. Now we integrate both sides. That is, the integral of dy, and here we also take the integral of the 6x plus 2 with respect to dx. Now the integral of dy will be equal to y, which will be equal to, now what is the integral of 6x? So the integral of 6x is 6 remains the same. The integral of x is x raised power 2 divided by 2. This comes from the rules of integration by power function rule. Loosely speaking, if we have x raised power n, its integration is x raised power n plus 1 upon n plus 1. That is, exponent is added by 1 and we divide by the resulting exponent. If we have x raised power 4, its integral is x raised power 4 plus 1 upon 4 plus 1. Okay. Now the integral of 2 will be equal to 2x. How does this sound like? We have only 2. Can we write 2 as x raised power 0? Because x raised power 0 will be equal to 1. Now what will be the integral of x raised power 0? Again using this method. So we have x raised power. We add the exponent by 1 and divide by the resulting exponent. So we get here x. So the integral of x raised power 0 is in fact equal to x, or the integral of 2 will be equal to 2x. Okay. Plus we add the constant of integration. We were also being given the initial conditions there. I forgot to write that. When or at x is equal to 8, x is equal to 3, when y is equal to 0. Okay, this was the full question. I forgot to write this part. So y will be equal to, so we get here 3x square plus 2x plus c. This is our general solution, but we need to find out the particular solution. That is, we need to find out the value of c here. Now the initial condition is being given us that x is equal to 3 and y is equal to 0. Now we plug y is equal to 0 here, so in place of y we write 0 is equal to 3. The value of x is being given us as 3, so can I write here 3 square plus 2 into 3 plus c. Okay, which gives us 0 will be equal to 3 3s are 9, 3s are 27 plus wait a minute, I have done some mistake here. So when I transposed this, it became 6x. Transposing this, it became negative. So it is here minus. So we have here minus. Obviously here it will be minus. Here again we have this minus. Okay. So we get here 2 3s are 6 plus c. So 27 minus 6 is 21. So 21 plus c is equal to 0, which implies the value of c is equal to, transposing it becomes minus 21. So our particular solution will be y is equal to 3x square plus 2x minus 21. This option, which I have not mentioned here because of the lack of the space, this should be the correct way. So how do we solve this question? I repeat it here. So if we are being given an equation in this form, we apply the separation of variable method that makes it easy to find out the particular and general solution. So we have dy upon dx. I transposed all these terms to RHS. Minus x became plus x and plus 2 became minus 2. Then transposing this dy, transposing this x here, it gets multiplied. So we have dy. So we separate dy's and dx's here. So we take the integral on both sides, solving them. We get this as general solution because we don't know the value of the constant here. To find out the specific or particular solution, we go to the initial condition that is being mentioned in the question. We put the value of x is equal to 3 when y is equal to 0 in this equation. That gave us the value of the constant, which came out to be 21 negative.